In this video we're going to work out the volume of this solid bounded by these two surfaces. So this surface here is given by this, and this surface here is given by this. So normally you don't get the luxury of the diagram. So let's pretend we didn't have this diagram and we have to work it out from scratch. So we need to understand, we need to have an understanding of what our solid looks like. So looking at this, consider the XY plane. So consider this consider this ZY plane. So imagine you've got a vertical sheet of paper. So ZY plane. So when you sketch your surface, it will look like this. It will look like well, make Z the subject. So Z equals 2 minus Y. So it has an intercept of 2 and a gradient of -1. So it looks like this. This is also at 2. That's why you get this straight line here. That's our straight line here. And looking at our surface, the absence of an x, means that when x equals 1, when x equals 1, so now you're looking at this vertical sheet of paper here, you're going to have this same line, intercept of 2, and it has a gradient of -1. So the absence of a z means that everything along here will satisfy this equation. So really you're going to get a trace. You're going to get a trace in the x direction. The absence of an x means you're going to get a trace. So anything along this diagonal line will satisfy this equation. Okay, so basically this is a plane where the gradient is -1. Now consider this surface. So consider the y-x plane. So imagine you've got a horizontal sheet of paper here. So this is our horizontal sheet of paper. So normally we would draw a graph looking like this, y-x. We would normally make y the subject. So it looks like 4 minus x, and then you square root, you get the positive version and the negative version, and then it turns out to look something like this. But this seems a bit complicated. So let's, instead of drawing our y-x graph, let's draw our x-y graph. And then so now this is easy to draw. Intercept of 4, negative quadratic. Intercept of 4 and a negative quadratic. So it looks like this. And then well, I want to translate this into, I want to transform this into this plane here. So hang on, let me just quickly flip it upside down. So hang on, flip upside down, flip it upside down, flip upside down. There, I've flipped it upside down, and I want to rotate it slightly. So now it looks more like our graph. So hang on, bear with me. So this line here is this line here. Well, anyway, the absence. So looking at this, the absence of a z means that any quadratic will be will satisfy this. So you're going to get a surface looking something like this. So you're going to get a trace in the z direction. So any quadratic of that form in the z direction, it will satisfy this equation. So now we're looking at the intersection of those two surfaces. So the intersection of those two surfaces is given by this solid. So now set up our triple integral to work out the volume of this solid. So the volume is equal to the triple integral. Hang on, triple integral, and let's try dz first, and then dy, and then dx. So don't forget there's a 1 here, but we can't be bothered to put that 1 in there. So z, that means the inner integral would be z, so it would be z equals something, z equals something, and then the outer integral would be y equals something, y equals something, and then the outer one would be x equals something, x equals something. So now looking at the inner integral z, so z, you're moving, everything's moving parallel to the z axis, so you're moving like this in parallel to the z axis. So you enter, hang on, you enter the horizontal plane, and then you leave that diagonal plane. Okay, and then if you look at this, because we're now considering the z, so we've got to move parallel to the z axis. So looking at this, you enter the horizontal plane, and then you leave the diagonal plane. Okay, so let's look at this one here. You enter the horizontal plane, and then you leave the diagonal plane. So when you set this up, you enter the horizontal plane. The z value here will be z equals 0, and then you leave this bit here. What is the z value right there? Well, the z value right there is what? Don't forget, this plane here is this plane here. So the z value there will be 2 minus y. So look at this. You enter z equals 0, and then you leave 2 minus y. So you leave that plane. You enter the horizontal. The horizontal z equals 0, and then you leave the diagonal plane. You leave the diagonal plane. So now we've got to consider dy now. So dy, hang on, let me clean this up. So now consider dy. Bear with me. So now consider dy. So dy, you're moving. Hang on. Dy, you're moving parallel to the y-axis. So this is the y-axis here. So you've got to be moving like this, parallel to the y-axis. Okay. Oh, by the way, now that we've taken care of the z-axis, this whole solid will lose a dimension, the z dimension. So the whole solid will collapse down to this 2D plane here. It will collapse down to this 2D plane. So now we're just looking at this plane here, okay? Because we've already taken care of the z-axis. Once we've taken care of the z-axis, the whole solid collapses down to this this plane here. Okay. So now we've got to consider moving along the y, parallel to the y. So parallel to the y would look something like this. Parallel to the y. Hang on, parallel to the y, parallel to the y, and parallel to the y, you would enter here, y equals 0, and then you leave at this this curve here, and then you enter y equals 0, and then you leave this curve here. So so I've got to rearrange this. I've got to rearrange this curve here. So I want to know the y value. I enter y equals 0, and then I leave the curve. Well, the curve in terms of y would be me rearranging this. So it would be, hang on, add y to both sides, y squared to both sides, and then well, y would equal square root plus minus but I don't care about the minus version because this is a positive version. So 4 minus what minus x, or I'm getting confused. Hang on. I think that yeah. So this line here is given by this. Okay. But here's the thing. I don't want to be dealing with square root when I come to integrate. There is a better option. Hang on. So rather than working with y, we're going to switch dy and dx around. So let's do dx first. Hang on. Let's do dx first. Dx and then dy. So you see y later on. Hang on, let me just change this. So we've done our z in the z direction. We now need to consider dx. So x equals something, x equals something, and then the outer integral will be y equals something, y equals something. So if you look at this one here, parallel to the x direction. So now you're moving parallel to the x direction. Hang on. You're moving parallel to the x direction. So you're moving in this direction here. You're moving like this. You've got to move parallel to the x-axis like this. So now you enter x equals 0 and then you leave this curve. You enter x equals 0 and then you leave this curve. So you enter x equals 0 and then you leave this curve. So now it's nice and clean now because x is the subject. So this would be 4 minus y squared. We don't need to be dealing with square roots when we come to integrate. So now that we've taken care of dx, so hang on, we are currently, bear with me, let me clean this up. We are currently dealing with this this plane here at the moment because z has collapsed down to this plane. Once we've taken care of x, we're going to lose an extra dimension in the x direction. So this plane here will collapse down to this whole plane here will collapse down because once we've taken care of the x, we're going to lose that x dimension, and then this plane here will then collapse down to this line here because we're going to lose the x dimension. So now we're going to this whole plane here will just collapse down to this line here. So now we're integrating from y equals 0 to y equals 2. So our whole integral is given by this thing here. So the volume of this solid is given by this. So now we are currently here. We are currently here. So now the rest is just easy now. We just got to integrate this with respect to z. So when you integrate 1, it will just give you z from 0 to this, from 0 to this. Okay, and then bear with me, and then we've got to put this into here. So that would be this, and then take away, put 0 into here, which would be 0. That will then give us this, and then now we have to consider this integral here. Integrate this with respect to x. So that will be 2x yx. So when you integrate it, it will then give you this thing here, from 0 to this, from 0 to this. So now put this into the x, put this into the x. That would then give you this whole thing here, and then take away, put 0 into here, it will be 0. So that will then take us to here, and now integrate each individual term with respect to y. So that will then give you this from 0 to 2, from 0 to 2. So the volume is given by this is your final answer. Okay.